Hello and welcome back to the channel. Now first of all, I'm hoping and praying that I've finally got this microphone sorted out. I think I have. User error. Helps if you've got it plugged in. But anyway, if you're looking at the screen right now, you will remember this if you've been following the series that I've been creating on how to make a game using Spectrum BASIC on the Spectrum. So at the moment, we have got our UDGs in place. Okay, our user-defined graphics have now been created. Today, as it says at the top of the screen there, I'm going to talk about ATTR collision detection. Now I know there's been a few of you out there waiting for this, trying to get your head around it. It can be difficult to get your head around it, but hopefully I may be able to help a little bit. I'm still trying to get my head around it, if I'm to be honest, but I've managed to get it working. So at the moment in our little game that I've created here, if I touch one of them if I touch the wall, I'm still bouncing off. Yeah, so if I touch a red robot, the ATTR has already been put into the program. Okay, all the screen string commands have gone except for the X up in the right hand corner. That is still working off screen strings. Everything else you see on the screen, all the collisions now are done with the ATTR command. Also in this video, I'm going to show you how, at the moment we've got our little man. Someone asked in the comments, how do I stop him from just bouncing off the wall like that? I want him just to stop at the wall and not be able to pass through it and just come to a standstill. I'm going to go through that with you as well on this video. Anyway, I'm going to take you away from this screen now. I'm going to go to a separate program because I think it will make it easier than trying to go through all that lot. Okay, that is what we're creating. So instead of me going through all that lot, I'm going to take you away from that now. There. And we're going to start afresh just so I can explain the ATTR. I think it will be easier than having all of that programming stuck up on the screen trying to get your head around. Anyway, let's get with it. Let's get started. Right, so what I've done is a little mock-up program here using everything that I've shown on previous episodes. Like I've got the in keys set up there, look, from 120. That then goes down to, where are we, 200. I've created a little wall as an obstacle. And you'll notice I've got the smiley face at 170. That's using the user-defined graphics on the video that I did last week, where I did an example of a smiley face and a sad face. So I've basically used those examples to put into this to create another example for our ATTR command. So at the moment, when I run it, we've got our smiley face and I've put an obstacle in the way. So what I want to do is when we hit that blue wall, I want ATTR to do the collision detection. So let's get into it and I'll show you how it's done. Okay, so ATTR, the function is very similar to screen strings, but it returns the color attributes, and there's calculations that we need to put in place for it to work. So I'm going to go through that now and hopefully it'll make some sense. If we do 160, and I'll talk you through while I'm doing it. So if ATTR, exactly the same as if it was screen strings, but we're using ATTR. So it would be Y and X because that's our character. Now this is where we do the calculation bit. What's it going to equal? So like I was just going to say, our paper color is 7. Our screen is white. 7 is the color white on the Spectrum keyboard. Okay. So we need to times 7 by 8. So whatever paper color you're using, you times it by 8. So 7 times 8 is 56. All right. But we've also got our ink color to take into consideration. Our ink color is blue, which is 1. So that 56 becomes 57. You basically add that on. Okay, so paper color times 8. So whatever your paper color is, you times it by 8. And then your ink color, you plus it by whatever that ink color number is. So if it's blue, it's 1, red 2, magenta 3, and so on and so on. Okay? So if it equals 57, then I'm just going to get it to beep just as an example, and then we'll come back to this and I'll show you a bit more, because you need to know what to enter if the character is bright in color, so if you've used the bright command or you've made it flash. But for now I'll just show you this. So I've put it at 160. Alright, now you'll see I've put it after our controls. So now, fingers crossed, when I run this, it should beep. Yes. And again. So it is, the program is recognizing that we are hitting that wall. Alright. Now, what about if that wall was flashing? So let's go down to 200. List 220. Enter. Let's bring that down. Let's make that wall flash, okay? Whoops. Flash 1. So let's go back to our ATTR command, which is at 160. Bring that down. ATTR, by the way, is on the letter L, cap shift, symbol shift, and then press the L button, gives you ATTR. So that 57, if we're going to make it flash, we need to add 128 to that 57, which will give us 185. So now our wall is flashing. Will it beep? Yes. And just to prove a point, if I put that back to 56, it's just going to go crazy because we've got the number wrong, we've got the calculation wrong. So again, we would have to add our flash command back to that, which was 128, add 128, add, what was it again? 56, so 185. There. So now if we want our blue color to be bright, you're going to use the bright command. So we want a bright blue. If I put bright 1, will it still work? No. Again, it's going crazy because the calculation's wrong. So we need to tell the attribute that we have added the bright command to our color blue. So for the brightness of the color, we have to add 64. So 64 add 56 is 120. What have I done wrong there then? So our screen, our paper color is 7 times 8, which is 56. I know what I forgot to do. Forgot to add the ink color. Like I say, I will show you all the mistakes because you're going to make them too. So it was 57. Add the brightness, which was 64. So it was 121. So I was one figure out. Let's see if it'll work now. Yes. So I'm glad I messed up there a bit, because it just shows you how you've got to get that calculation correct, as it's not going to work. So now we've got our attribute working. So when it recognizes the color blue in bright 1, so that wall's a bright blue, although I can't personally see the difference, it will now make that beep noise. Now I'm going to get rid of that brightness, and I'm just going to return that back to 57. And I'm just going to run that again. Yeah, still working. Right, I told you at the beginning of the program I'm going to show you how to stop the character from going through the wall. So if we pull down our attribute color, so instead of if we put beep, we'll keep the beep in there. Then we're going to put let y equal y1. Whoops. Let x equal x1. Now hopefully I won't be able to go through the wall. Okay, so someone asked in the comments how to do that. That's how you do it. So if you remember in previous episodes where I went through this little piece of the program here, where it stops the character from flashing when it's moving, we assign another set of variables to our y and x positions, which is located at line 110. So to stop our character from going through the wall, when it hits it, it's basically the program is telling it to go back to y1 and x1, which was its old position, if that makes sense. So let's just pull that line down again. 160. Whoops, what's going on? List 160. Let's bring that down to the bottom. So that's what you need to put in. So the person who was asking that in the comments, that's all you've got to put in. If y equals y1 and x equals x1, so let that happen, okay? And that will stop him going through the wall. Obviously you don't need to have the beep in there. I just put that so we can hear that it's actually hitting it, but I can't go through that now, look. So that's basically how the ATTR command works. So let's just show, if I lit our little face, what colour should we have him? We'll have him in white. Yeah. I'm going to go back up to line 10 and I'm going to put 30 paper. Come on, get your act together. Paper black, border black. All right. So now the screen is black. Now ATTR isn't going to work because we've now got a black screen, black paper color. So let's pull down our command, list 160, our ATTR command. We need to change that now. So paper color is black. Well, black is 0, so that's going to remain as 0. So this is an easy one. If it's 0, we just need to put 1 in because that's the color of our wall. So 8 times 0 is 0 plus ink color, which is blue. There you go. Okay. So let's now, where is it? Line 200. Let's now change that to red. Again, it's not going to work. So ATTR needs to be set to 2 because red is 2. And that's basically it. So whatever your paper color is, times it by 8 and then add your ink color. Now will that work, that 160, if I put it at, say, line 125? Well, let's have a look. So what I'll do is I'll just change that to 125, list 160. I'm just going to put a rem statement in front of that. Will it still work? No. This is what I'm saying. It has to be after the controls. Okay? So after the controls, so after you've moved your character, the program is then looking to see if you've hit anything. And that is basically it. That is how the ATTR command works. And I'll put up on the screen now those calculations I was just talking about, so you can absorb that and take that in. Now let's say we want our little smiley face, when it hits the wall, we'll have the sad face come up. And what you could do is you could go sub this, but this is only an example, so I'm not going to mess around with go subs too much. But you could say if ATTR YX coordinates hit the color 2, go sub somewhere else in the program, do something, then come back. But I'm not going to do that. I'm just going to say print at Y. Whoop. And I'm going to do put our sad face in. Alright. So of course, probably what will happen now is it will just leave a sad face every time we hit the wall. Whoop. Another mistake. I always do this. I always mess up and forget to put the print at. There you go. So we're creating a little bit of an animation there. We could slow it down if we wanted. Could use the pause option, but sometimes, I don't know with the pause option, if you're pushing a key at the time, it's not really going to do it. Let's try it. Nah, not really, see? Maybe we could put a loop in there. I'm just messing around now, just to see if I can get this to work. Just trying to think of a quick way of doing it. See his mouth moving? So I'm basically just trying to show you how you could perhaps generate a little animation. We could increase that. Go to 20, shall we? There you go. So now when we hit the wall, our little man pulls a face. I mean, you can ramp that 20 right up if you want, just to slow it down even more. Cool, hey? So there you go. What more can I say? That's how ATTR works. I've already put that in the video, in the little game that we're making. So I can't really see the point of going back there, just to show you basically what I've just shown you here. Alright, so I just wanted to say before I go, thank you so much for everyone who has given me the support to carry on making these videos. It means a lot to me. I enjoy making them. I enjoy making videos. If you've been looking through my channel, you see that I've done some crazy stuff before. I've made animations. I've tried a little bit of comedy and so forth. What I'm really enjoying doing is actually creating stuff with a program on the Spectrum, because the Spectrum is what I grew up with as a kid, and I always wanted to make games, but back then a young mind had other things it wanted to do, go out and play on the BMX bike, chase girls around, you know. So, but at this age now, I really want to share as much as I can, as much as what I've learned anyway. I mean, I am no guru at BASIC. Like I've said many a time, I'm not fluent in the language, but if I can help someone with what I've learned, then life's a good one. It's a bonus. So, again, thank you so much for watching. I hope this video has been of some help, and I shall see you on the next one.